All right, so chapter 7 is where we start learning about exponent properties, and something that we'll see come January, exponential functions. Exponential functions are the first function that we learn about that is non-linear. Because if you look at the exponential function poster in the back, you cannot connect the graph with a straight line. It is curved. Okay? That's because in an exponential function, the variable is in the exponent. But before we get to those functions, let's first learn about those expressions. Okay, so in lesson 1, lesson 2, lesson 3, we're going to be looking at like exponential expressions and different properties. Okay. So this is going to be 7-1. Okay. Multiplication properties of exponents. Okay. Exponential multiplication properties of exponents. All right, so let's just dissect each of the different parts of an exponent, just because we really haven't talked about them since chapter 1. Let's talk about each piece. Okay. The 3 is called the base. Okay. The 4, we could use the word exponent. We'll also refer to it as the power. Okay. Now, how would I expand 3 to the 4th? What is another way that I could write it? And notice, I'm not evaluating it. Go ahead.
That'd be 3 times 3 times 3 times 3.
Okay. If you understand how to expand exponents, you could do every single one of these problems without remembering what the property is. Okay? Because if we understand how exponents work and like simplifying and things like that, we could do every example and I would not have to give you each property. So there are going to be three different cases that we're going to be looking at today. Okay. This first one is going to be where we multiply powers with the same base. Okay. So for example, 2 to the 3rd times 2 to the 4th. So if I have 2 to the 3rd and 2 to the 4th, how would I know you're still writing, but I think it's fair for me to continue to ask. How would I rewrite in an expanded way 2 to the 3rd times 2 to the 4th?
2 times 2 times 2 times 2 times 2 times 2 times 2.
Good. Here is 2 to the 3rd. Here is 2 to the 4th. How would I then simplify this? Good.
2 to the 7th.
2 to the 7th. So if I'm multiplying with the same base, what am I doing with the exponents?
Just adding them.
This is called the product of powers. If I have a to the m times a to the n, it is a to the m plus n. Okay? If the bases were different, you could not do this. This is why we're saying we're multiplying powers with the same base. Okay? We just add the exponents. Okay? So, example 1. simplify each expression. R to the 4th times negative 12 r to the 7th. All right, so how do you think I'm going to simplify this? Are we going to do anything with that negative 12? No. So it's going to be negative 12. Because it's negative 12 times 1, right? The coefficients.
R to the 11th power.
B. Six C D to the 5th. 5 C to the 5th D squared. How do you think we would do this one?
5C.
Well, let's maybe work on like each piece first.
So maybe
Go ahead.
like C6.
Yep, C to the 6th. Okay. What's another piece of this answer?
D to the 7th.
D to the 7th. Okay. And then what am I going to do with that 6 and that 5?
Those four. 30.
Okay. What number is in the exponent of this first C?
1.
Good. The mistake that people make is they think that that is 0.
Well, that wouldn't be anything. Well, then.
Stay tuned for lesson 2. What's important is that something raised to the 0 is not 0.
Well, if it was 0, then there wouldn't just be an exponent, right?
No, there would be.
What? 0.
Yeah, we would write C to the 0. That's different than C to the 1st. Yep. Good. All right. So that is a few instances of product of powers. But now, what if I'm gonna kind of label these a little bit, like put some bullet points. It's almost like different headers within the notes.
Wouldn't C to the 0 just be C?
No,
Wouldn't
that's
it
C to the 1st.
Wouldn't it be 1?
Yes, it is. Do you remember why it's 1?
Wait, what?
Wait, because like, if to the first it would be like.
All I know is every like number times 0, like in there is 1.
Not times, but with the exponent.
Yeah.
It is. We'll talk about that tomorrow when we do lesson 2. What if we raise an exponent to another exponent? Let's say we have 2 to the 5th raised to the 3rd. What would be another way of writing this if we're expanding it? Go ahead.
Will that be that 2 times? Well, 2 times 2 times 2 times 2, and then that 3 times.
Wouldn't that
Yes.
be a 2 and then a 15?
Yes. Right? 2 to the 5th raised to the 3rd would be 2 to the 5th times 2 to the 5th times 2 to the 5th. And then using bases and exponents, 5 times 5 plus 5 plus 5 is 15. Well, 5 times 3 is also 15. So this is called power of a power. This is where if I have a raised to the m raised to the n, it is a raised to the m n. Okay? So it's almost like if you see the parentheses, what's one of the first properties we learned in chapter 1 that dealt with parentheses? Distributive. Distribute is always multiplying. I'm distributing the n to the m.
But not the a.
Correct. That's different.
Wait, what's the where you like have the exponent next to an exponent? Like, it's not parentheses, but it's just, or unless it's the same thing.
Yeah, I would say that's an exponent next to an exponent.
Okay.
Yeah. Example 2.
Once you see the calculator.
Oh, do I need to? This is the first time in like 3 years that I've actually done these lessons within like a normal class period, because over the last 2 years I've done exponentials. I've started them in J term, and so it's like I had to chunk everything up. So it's like I would have done this lesson over like 3 days.
So you haven't done this in 3 days?
No, I've done this. It just has not been in like a normal class because I've been doing it during J term. So.
So he has got 2 steps ahead.
Yes. Yeah. I wouldn't. So like last year. So it's like last year I didn't get to this until like after Christmas.
Oh, wow.
So
we're like
When they
a
take the
week
test
ahead.
though.
Oh, you're I don't know why, but yes, you're like multiple weeks ahead.
So does that mean we'll have
When
to
did
do
they take
extra
it?
work at the end of the year? Like we're gonna try to squeeze in more math?
Yeah.
Wait, yeah, we're gonna try to squeeze in
Time
more
out.
math.
Simplify.
Wait, what?
I'm excited about that then.
I'm not.
Wait, so are we gonna finish out this
I'm
book?
squeezing more math?
Probably
No,
not.
I'm not excited. I'm like, what?
What would you do in a circumstance like this? 2 cubed whoops.
What was it?
Cubed.
3 cubed?
Yeah.
Squared.
Oh, it's, okay.
18.
So so I see all these exponents next to each other. What am I going to do?
Distribute.
Yep. So
Is it just 3 times 3 times 2?
yes, what is that?
18.
And 2 to the 18th. If the book asks you to evaluate, because these are just numbers, it is 262,144.
Oh my goodness.
And you just use the calculator to do that.
Oh, so we can use our calculator for that.
Yeah, but like I would want to see this. Your calculator will not show that
How do you do the negative exponents?
tomorrow.
Clark's way ahead of us.
Yeah, Clark's like thinking about everything.
I mean, you would have seen these whether it was 7th grade math or pre-algebra.
I mean, if the 2 3s were just negative, wouldn't it just still be the same?
Yes, but it's like, what do you do when one of them is negative and one of them is positive?
Like
It's
a
still negative.
Right, but then what is?
Doesn't it change?
It does change. It becomes a fraction. He has a good memory.
We didn't even learn, I don't think we learned
Yeah, we
this
just
last year.
learned this last year. This is
I bet you did. It was probably like
Like multiple exponents?
maybe not exactly like that, but I bet you did this in pre-algebra.
We did like the stuff up there.
Yeah. How about this one then? Ooh, now there's a 3 inside.
That's a 3. Wait, that's a 3 or a 2?
Well, that's a 2, but that's a 3, and that's a 3. What do you think we would do here?
You don't distribute it to the 3, right? The exponent?
We do.
Oh,
So what's 3 to the third?
18.
Ooh, try it.
9. Wait, you said 3 to the third?
Third.
27.
27. B.
Oh.
But why is it distributed? Why is it distributed to the
Wait,
3 though?
oh yeah, B is 6.
Why is it distributed to the 3 though?
Because that 3 is inside of the parentheses. This is the same thing as, so like, remember, we can always be thinking about these problems as we can always expand and do the math. This is the same thing as 3b squared times 3b squared times 3b squared, right?
Why is the other one like that? Like the one you did before?
This one?
Because
You
Didn't
can
need
do
to.
one,
because 2 is within the parentheses, so why does that make a difference?
Because the 2 here is the base of the exponent. This 3 is just a coefficient.
the base of that is like 1, right?
Yes. No, the base of this is b.
The base is 3.
I think about
Like
it.
1.
Here.
This
I
is-
think-
this is confusing.
No, I think you're just overthinking it. This 3b squared raised to the third is the same thing as 3b squared times 3b squared times 3b squared. What is 3 times 3 times 3?
27.
Which is the same thing as 3 to the third. And then b squared times b squared times b squared, well, that is just b raised to the 2 plus 2 plus 2, which is 6, which is the same thing as 2 times 3. So this is then just one subtle way of telling you let me just make sure it's the last property. Yes, just telling you our last property is called the power of a product. The power of product is essentially if I have an expression like this. If I have something in parentheses, it's a product, and I'm raising it to a power, therefore power of a product, we are just distributing we're distributing the exponent to each piece.
Why wouldn't you just multiply the 2 and then?
Because you can't always. Like, I can't, like 3b squared, that's as far as it can
Is
go.
it because there's an extra variable in there?
Yes.
But yeah, but like if there was no variable in there, if it was just like 3 times 4 and the exponent would be like 2.
Yes. Yes, you could just do 12 squared and you get 144.
Okay.
All right. Now, here is a new term that everyone's going to learn. These are, I'm going to put it up here. These are all called monomials. Monomials.
Maybe.
Maybe.
It seems familiar.
A monomial is one term. That term could be a number, a variable, or the product of a product of the two. Okay. So all of the answers that we gave from example 1 to 2, those were all monomials. This term is important, especially for when we get to chapter 8, okay, which will be third quarter.
Which means we probably would have forgotten all about this.
Nope. Problem. All right, so example 3.
Yeah, I'll probably forget.
I doubt it. It'll be. I'll tell you what it is, and you'll be like, "Oh, I remember what that word." You'll recognize it. I mean, it's the first time. Like I've said before, Don't doubt yourselves.
Oh, wait, what?
Repeat that one.
Marcus was sleeping.
I didn't hear you.
Don't doubt.
Said don't doubt yourselves.
Oh, okay.
Yeah. Okay.
Wasn't it also good to doubt yourself sometimes?
I mean,
I mean, if you're trying to jump from like,
You
trying to
can't-
jump, just like,
I think I can jump over this keg.
yeah.
Okay.
express the area of a triangle with height 4a and a base of 5ab squared as a monomial. Okay. All right. That's a monomial. Okay. Okay. What's the area of a triangle?
Area of the triangle.
Yep. What's it? What just like the formula.
Oh,
Height
the BH half, whatever.
Height.
Oh my word. Yes.
Height times weight.
Yeah, that's exactly what I said.
Yeah.
Base times height divided by 2. I do 1/2 base times height.
Yeah.
Tomato, tomato. Potato, potato. They're all the same. All right. So.
Are we gonna have to know like all the formulas for the exam?
Oh. I mean, when you say formulas, what are you talking about?
Like for all the different shapes and like area. And
Oh no. This is like one. This is like one of the few
Well,
times.
we're not in geometry, are we? We're not. This is algebra, so it's not.
Right.
We don't have to.
Hang on, but next year, will we have to know all that?
And what do you mean?
In
In
geometry.
geometry?
Probably, man.
Well, geometry is just like angles and stuff, right?
And like how angles have relationships to one
I hate
another.
No.
Yeah,
I know.
yeah,
That's gonna be really bad.
Geometry's like
yeah.
But who teaches us geometry?
Mrs. Sterrett.
Oh.
Yep, she does a good job.
Oh,
wait, so we have Mrs. Sterrett next year.
I already
so
have
you-
it.
Yep.
And then we have you again the next year.
Yep, and the year after. And the year after.
But the next class, the non-honors would have Mrs. Sterrett. They won't have you, right? Oh, no, they have Mrs. Griffith next year.
Yeah, so Mrs. Griffith does the honors 7th grade math, which obviously most of you had last year. And then she does the pre-algebra. So she does all the pre-algebra.
Yeah.
And the 9th grade algebra.
Oh.
So your classmates who are in pre-algebra with her right now will have her again next year
For this class.
What all does
for this class.
what all does Mrs. Sterrett teach?
Mrs. Sterrett does all the geometry, the regular Algebra 2 class, and then quantitative reasoning.
That sounds difficult.
What is it?
Quanti-
I've heard of that.
It's called quantitative reasoning would be like if students are taking Algebra 2 and they could be in the honors track, they may not be in the honors track, but then they don't want to go on and take AP Pre-Calc, which is what I teach. It's like it's like a combination of like stats, probability, logic, and stuff. Oh, don't break your pencil, lead.
Quantitative reasoning.
So,
What's trigonometry?
Trigonometry. I can't even say it.
What even is that?
Yeah, trigonometry. What is that?
let's find this area first, and then I'll tell you. All right. So I'm given the base. I'm given the height. I'm multiplying. I'm using some of the rules that I have told you about. So,
That'd be
what's 5 times 4?
20.
Cut in half.
5.
10.
Oh.
What's A times A?
A
squared.
A squared. Example 4.
Oh shoot, wait, I didn't do that correctly. Mark, you stopped on.
Fall asleep, man.
You need some coffee.
Yeah, I forgot we had history homework last night.
Did you do all of it?
No, yeah, I was looking at it for like an hour.
You
did
study all of it?
Yeah.
It's not even due.
Are you serious?
Did you check Jupiter?
I didn't even do it yet.
No,
I did like half.
It's not. That's why I looked. It said it wasn't due, so I didn't do it.
Why would you do all
I
of it?
wouldn't. No, sorry. I wouldn't waste my
an hour.
time.
I got done like 12.
Did you guys
And you
finish
did it
the
all.
English
Yeah,
homework?
I did something in like an hour. I got looked up some of the answers and then I looked through my notes or something.
You know, that's why it's called a study guide.
You probably got the ones that you looked up for
Some of
100%.
it is mine.
Why?
Because
Alrighty.
Google, and it's
I-
different.
Here's our last one for today.
It might still be.
As you write this problem down and listen, trigonometry is basically you're taking things that you've learned about in geometry, not all of it, but some of it, and you learn that some of the like triangle ratios are functions, and you can graph them, you can solve equations with them, there are story problems with them.
Are we gonna take that class ever?
You would take that as juniors, if you stay on the honors track. Yep.
So seniors would take them though.
Seniors could take it. I've not had any seniors take it though.
Oh,
And this is only the second year we've had. This is only the second year pre-calc has ever been offered as an AP course.
Is a junior and 11th grader?
The seniors usually not take math.
Select seniors do. In my mind, if everybody has different reasonings as to why they stop or whether they go on, but it's in my mind, it's like you have the opportunity to take pre-calculus so that you can take calculus in high school, so you don't have to take math in college.
So you could take calculus as a senior. Well, I mean, we
Yes.
could, and
Yes.
then we wouldn't have to take it in college.
That as long as you get like a 3 or a 4 on the AP exam, you would earn that.
But
College
what if
math.
what if on a college degree that has nothing to do with math?
Yeah.
Because that's a great question. No matter the degree, you have to get 120 credits in college to earn a college degree.
How many credits do you have to get into college?
Well, that's a different question.
Wait, what if?
One second.
What if what you're going to college for has like literally nothing to do with
I
academics?
just have to write so many essays.
Hold on. Great questions. A squared to the third. What's that going to change into? A squared to the third. A to the
Yeah, 6.
A to the sixth. That is one thing worth pointing out. With these exponents, there is no like 2 to the third becomes 6. It doesn't become 5 because we're not doing the same bases. Right. So then this is also b to the 6th. What is negative 4 squared?
Oh, wait, what? Oh, negative 4 squared?
Not negative 16.
I didn't. Wait, 3?
Positive 16.
Positive 16. And then a squared is, a squared. Ooh, now we're squaring this. Okay. Clark, since you have your calculator out, can you tell us what 16 squared is? Remember, parentheses are your friends.
256.
What's 256 divided by 8? I think it's 16.
40.
Yeah. Wait, 32.
32. What is a squared squared?
A to the 4th.
So what's a to the 4th times a to the 6th?
Huh?
What's a to the 4th times a to the 6th?
8 to 10.
Ben, we're just putting
Yeah.
them
Parentheses,
together. We're just putting them together.
and then the exponent rules that we've learned in this lesson. So this is PEMDAS.
Wait, how did you get like 1/8 from?
Yeah, I've had a lot.
One-
It used to be 1/4.
1/2 cubed.
Cubed.
Oh, it's
2 times
I
2
didn't
times
see that.
2 is 8.
Oh.
So, you're asking great academic questions. The reason I think everybody should take calculus, who can, is because it's not just about math. It's about problem solving.
You can choose to not take it?
In high, in,
Yes.
the
Like,
senior
what
year.
happens if you don't? Like, do you just?
Don't take math your senior year. And then what happens is you might take math in college.
Which might be way more difficult.
No, but it'll be stuff that you've already learned and you're wasting money.
That's true.
I don't like wasting money.
I wouldn't take math for what I want to like go to
And then,
college for.
so, I
But
got
but there are problem solving skills in math that are going to be to your benefit. So
So, but why does the big picture?
Benjamin,
So, I've always had this question. So, why is there stuff like pre-calc and calculus and then like pre-algebra and algebra? Because it's all the same.
no.
You're not
It's
learning.
not.
You're,
Oh,
there's not like
No.
a whole lot that's.
oh, it is so different.
No, it's not. This ain't that much different than last year.
You know so much more than Mr. Hallbed. You know so much more than he does, don't you?
What?
You didn't even understand.